In the previous video, we have taken a look at how exactly the structural formula of any hydrocarbon is framed. Can you recall how we framed the structure of methane and ethene molecules? Yes, carbon chains first, followed by the bonds of hydrogen. The structures appear like these ones. Now let us understand another way of representing the molecules. Let us draw the electron dot structure. What does it mean? First, let us discuss how each atom is drawn using this style. The valence electrons in the atom are drawn using a dot or cross around its chemical symbol. Something like this. We could also have cross marks instead of dots. For simplification, we can even draw a circle with the chemical symbol of the element written in it and dots or crosses near the edge of the circle. Something like this. That's how individual atoms are drawn. What about the molecules now? Simple. The entire molecule will be represented by atoms present in it, but drawn using this structure. Shall we take an example to understand this? We have seen the structural formula of methane. Was it something like this? Yes. So now we will represent this using the electron dot structure. First thing we do is draw a circle with C written in it to represent carbon atom. How many valence electrons does carbon have? It has 4 valence electrons which are used to bond with 4 hydrogen atoms. So we represent these using the small crosses made here. We know that there are 4 hydrogen atoms that will be bonded with this carbon. And each hydrogen atom is drawn like this. We use just one dot in each as a hydrogen atom has just 1 valence electron. Now what next? All we have to do is join these 4 hydrogen circles with our carbon circle. Do we get something like this? That's correct. This is how we get the electron dot structure of methane. Even though it has crosses, it is still referred to as the electron dot structure. And note that dots and crosses can be used interchangeably. For methane, we could have started with carbon atom having 4 dots and each hydrogen atom having 1 cross. The final structure would have looked like this. This represents methane too. I think we should try out another example. Can we try drawing a similar structure for ethene? We have seen the structural formula of ethene before. Let's begin with our carbon atoms first. 2 carbon atoms each having 4 crosses at the corners like this. Now we know that since the member belongs to the family of alkenes, it has a double covalent bond between the 2 carbon atoms. That means the 2 carbon circles will be joined together having 4 crosses between them. Yes, here the double covalent bond is shown using 4 crosses. 4 electrons are being shared between the 2 carbon atoms. What next? We are yet to introduce the hydrogen atoms that each carbon is going to bond with. We draw 4 hydrogen atoms with 1 dot each. Now can we join the respective circles? These 2 hydrogen atoms will bind with this carbon atom. This shows that each of the 2 hydrogen atoms having 2 electrons and this carbon atom has 8 electrons in its outermost shell. 4 plus 2 plus 2. These are 2 single covalent bonds. Similarly, on the other side, we connect the 2 hydrogen atoms to this carbon atom using the single covalent bonds. Now this carbon atom too has 8 electrons and each of these 2 hydrogen atoms has 2 electrons. And with this, the electron dot structure of our ethene molecule is completed. Now let's try something interesting. We need to draw the structural formula as well as the electron dot structure for a higher compound like butane. Give it a try. Shall we begin with the structural formula first? Let us first draw the skeleton of carbon chains. How will it be? Something like this? But wait, can't we draw the structure somewhat like this as well? So far in all the hydrocarbons we've looked at, there were just 1 or 2 carbon atoms in them. That made it easy for us to show the carbon chains. For methane, we had just 1 carbon atom, so the carbon chain looked like this. For ethane and ethene, the carbon chains look like this. 2 carbon atoms can only be joined like this. There's only one way. And this bond could be single, double or even triple for that matter. But in the case of butane, we have 4 carbon atoms. So which of these combinations is correct? Well, both the structures are correct in their own way. That is because hydrocarbons of higher orders even have side chains and ring structures. Let us get to know about the branched and ring structures of hydrocarbons in the upcoming videos.